Okay, I got another puzzle for y'all. Uh, these are entropic lines. These have all the digits 2 through 9 in them. There's a pivot point. A certain distance away increases the weight upon it. So anything down here has a multiplication of 1, this is a multiplication of 2. There must be even on both sides. Kropke dots. Black is 2 to 1. That's consecutive, and that's the puzzle. Let's begin. So right away, we already know that this is the digits 2 through 9. So, what do I know? Well, this must be half of this in order for it to weigh the same. So that means that this can only be the digits 2, 3, 4. And likewise, this can only be 4, 6, 8. Same thing that we can discover here. This has to be 4, 6, 8, 2, 3, 4. This means that we guarantee a 4, I think, in here, because it's either 2, 4, 4, 8, that's one pair, the other one is 3, 6, which means we need to have a 4. Actually, because we have to have a 4, no matter which one we choose, we exclude the other of that, so this has to have 3, 6, and 4. Whoops. Crud. Corners. 3, 6, 4. This can't have 3s. There we go. So since that has to be 3, 6, 4, then we have 2, 3. Like this. It has to be 3, 4. 6 excluded. So we have these. Sweet. That's kind of cool. So we have 2 and 8 as our other option here. Do we have any guaranteed somethings? Actually, this probably can't be 4, 8. Because of how big it is over here. I'm not 100% sure, but let's... That's 4, 8. Did we get rid of 8 there? This has to be 3, 6. This is 9. That's 12. 36. That's 9. Which we have to get to 27 here. Which we can do, but with this... That's 27. Can we get this to equal that? 21... wait a second. I'm a little too heavy on this side, actually. 12 times 4... Oh, sorry, 12 times 4 is 48. Not 40. Okay, so 48 over here. So then we have 9, so we have 39 to deal with. 27, we have 12 still leading on this side. This equals 9. Then no matter what we put here, however, so even in our best case scenario, where we minimize the possible weight of this side, that's 12 times 4 is 48, 54, 59. And this, when it's maximized given this, would be 9 times 4, total 36, plus 14 is 50. So that cannot be 4, 8. Which means no matter what, this is our small digit, and that's our medium digit. Cool. Which means those are both red. Which means neither of these are yellow. That has to be blue and red as our possible options here. Which means that's blue-red. Which means that's blue-red. Cool. This probably can be 3, 6. Actually, I wonder if this can be 2, 4. If we can make that 2, 4, maybe that'll break as well. Maybe that's what we have to do here. Actually, let's do this. That's a 2 to 1 ratio. That's consecutive. So, This can't be a 1-2 pair. Because then this would have to be a 3. That breaks everything. This could be 2... Actually, if this is 2-4, then this could be at most a 5. So it can't be 2-4. So this also can't be 2. Could it be 3-6? It could be 3-6. Because it could be 3-6-7. That's kosher. So let's do 3, 6, 7 as one of them. Could we have 4-8? We can't have 4-8 that way. Could we have 6-3? 6-3-4. No, we can't. So this can't be a 6. This can't be a 3. But this could be 8-4, because then that could be a 3. So this is 7-3. So we have 3-6-7 or 8-6-3. Sorry, 8-4-3. No matter what, there's a 3 there. I'm just gonna get rid of this. Unhelpful. But yeah, cool. So that means that we can't have any 3s there. That's actually kind of neat. The question is it 3 consecutive to a 4 or 3 doubling to a 6? That's cool. Ah, we have a 4-6 pair now. Do we get anything interesting from that? If this is a 4, that's a 6. Actually, wait a second. I'm just thinking something through right now. Just give me a second just to process. So, if this is a 3, that's a 6, that's a 4, that's a 3. These would both be 3. These cannot ever both be 3. So those are both a 3, then we'd have it here. Cool. I really do want to try the 2-4 combo here and see if it breaks anything. No matter what, that forces to be a 3. Whoops. 3-6, that's 9. 9 times 4 is 36. That's just 8. We know that we can have a 2 here. Ah, wait a second. Parity. We could use parity here. We only have... So, okay, so these are both even numbers. This is even, that is even. Oh, this also should be 8. That should be 6. So, this is always an even number. These are odd times whatever parity that is. So if this number is even, if this is the 8, then all these other ones are actually odd because it's 3 distance away from that. 1 distance, 3 distance. So this can never be, that can never be an 8. Because if that's an 8, then we know they will not align. Actually, I think that's just always generally true. Because no matter what, this is going to be... I don't know, it could be 3-6. Nope. Okay, so because it could be 3-6. We don't know for sure. Okay, so let's... Actually, this is always a multiple of 3. That's always a multiple of 3. That's always a multiple of 3. That's always a multiple of 3. These have to have the same 3 parity. Like the same, yeah, rarity, I guess. Because this will always equal 0 mod 3. That'll always equal 0 mod 3. That will always equal 0 mod 3. And that will always equal 0 mod 3, which means these must be the opposites. That means neither of these can be a 9, because if one of them is a 9, the other one also needs to be a multiple of 3, which they cannot be. So this is a 5, which is 2 mod 7, or a 1 mod 7. So if this is a 5, then this is a 7, and this is a 7, and this is a 5 or an 8. That's fine. Okay. We just whittle down another one. That's genuinely pretty cool, actually. I'm gonna have to do that every time, aren't I? So this guy needs to be bigger weight. If I put a 9 here, that'll just ridiculously overinflate this number, and we can't recover here. I think that if I put a 9 here, that'll be 27 on top of this, which is 24 plus 3 is 63. And there's no way to recover here, like, at all. Nowhere close. Which means this has to be the 9, if this is the case. Which means that's, what, 9 times 3 is 27, 33. So we still need 3 more on this side. If that's a 7, that's going to have to be a 5. And then that will work. Yeah, no matter what, because of the 8. The 8 screws us over. We don't have enough. Okay, so if I put a 5 here, then as we said before, that has to be a 7 in order for that to work, because that's 10, that's 7. Together, they have the same parity of 9s, one higher than a multiple of 3. But this is 10, that's 7. That now evens everything out, and we haven't filled in this digit yet, so that can't be a 5. Could that be a 7? Well, that's a 7. Then we could have an 8 here and a 5 here, but that's 15, that's 14, and we've already overleveled this side, because we had still had 3 more. Which means, based on all of this logic that we've done, we've just now officially shown that that cannot be a 2, and that cannot be a 4. Okay. Yay. This is a dense puzzle to start. Frig. Oh, well, I know this is always going to be yellow. That's always going to be red or blue. I can be brown, I can be blue, I can be violet sky. I cannot sing. Okay. Let's... I don't know. What could I try whittling down here? Well, actually, so this is still always going to be a multiple of 3. 3, 6, 4, 8. It's 9 and... it's 9 and 12. And this is still also going to be a multiple of 3. It's going to be 2, 4, which makes 6, or 3, 6, which makes 9. Which means these are always a multiple of 9. This are a multiple of 3. That's always a multiple of 3. That's always a multiple of 3. That's always a multiple of 3. Which means these still need to have the same 3 parity. Which means still, they cannot be 9. Frig. Excuse me. So, 2 is 1 less. 5 is 1 less. 8 is 1 less. 7 is 1 more. So they have to be opposites because of their 2 3 separated. So that's fine. So if one of them's a 7, actually that means that one of them has to be a 7. Because if one of them's a 2, the only thing that would opposite it, because 2 times 2 it makes 4. So then the other one has to be a singleton. So if this is a 2, this has to be a 1, which is the one that fits a 7. This has to have a 7. Neither of these can have 7s in them. Okay. That's cute. And now I could just go with parody stuff. No matter what, I'm always going to have one even number. One of these is going to be odd, one of these is going to be even every time. Yeah, because now we have one of them has to be 3, 6, which is odd. Combination makes. Oh no, but this is always going to be even because it's on a multiple of 4. Balls. So this is the one that determines whether the parity works out or not. Crap. No matter what, we can always ignore that. But yeah, this looks like it's about to do a 3 parity. Like it has to be. That's the only thing that would make sense to try whittling that down by using Thrarity. I'm tempted just to bifurcate one more time. Just put like a 3 up here and see if that does anything here. Whichever one of these is 7. Actually, one of these has to be a 7, which is a red. Which means there's going to be a red next to this. Cool. That's just a cute little detail. So one of them's going to be red. The other one could be a red. But can never be a blue. So neither of these are a 2. It just can't be a 2. So it could be a yellow. That's fine. It could be yellow, it could be red. So if there's a 2, it has to be one of these guys. But it doesn't have to be a 2. These have the same alignment? Da, 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 da. Okay. So these can't be 8, 9. We need to have a 9 here. Which means since there has to be a 9 here. Yes, they could actually have the same alignment. There's no reason for them to be in the same alignment, rather. Yeah, so there has to be a 9 there, period. If there's a 2, there has to be the 2 there. But if I had a 5, then the other one couldn't be a 9. Here's why. So, this, these are all the same color. And that color isn't blue. We have this. We just know that those are all the same, which I'm just going to mark with purple for the sake of pointing it out. That means that these cannot be 2 different colors. They cannot be yellow and red. If I put a 5 somewhere, the other one has to be a 9, because we have to have a 9 up there. We just don't have a choice. So if I put a 5 there, which is a yellow, the other one has to be a red, which means it has to force a blue up here, which is a contradiction. That can't be 5. Which means this can't be 8. That's a 5-7 pair. And just double check that works. We choose 5 up here. That will be 10. That will be 7, which are a difference of 3, which works. Likewise, 14 versus 5, difference of 9 still works. So now we're forcing a 9 there. Now we can probably figure out if this can be a 2. Because if one of these is a 2, it's going to dramatically yank down the other side's value. And if we put a 9, it's going to dramatically inflate that side's value. Is there any way that this could be a 9? If that's a 9, and we minimally put this as 2, 4, 3, 6. We put an 8 over here. That will offset it actually significantly. Yeah, because that only counts now for 3 on this side, essentially. So yeah, that could actually work. But if I put a 2 here, then everything goes tits up. So yeah, that's not going to be able to work. That's 3, that's 4, 8. So that's 12, 13, 14, 15, 16, 17, 18. We only have 18 on this side. But this is forcing that to be a 9, as we've got 9 times 7, which is already 63, way too high. Okay. Which means that cannot be a 2. Can this be a 2? If we do 2, then that's 3, 6, 4, 8, and might actually cause this side to weigh too much. Then that has to be a 9. That's 12 plus 27 is 39. Then we have 6 plus 9 times 4, which is 36. So we have 42 on this side. Yeah, we could do it. We can make that a 7 out of 5. That would work out. That is one valid understanding of this area. Okay. This has to be odd. This has to be even. Which means so far this side is odd. That means whatever this sums up to is the opposite of this. That's always even. If this is 3, 6, so it makes an odd number. No. If we make it 4, 8. Yeah, and that forces the 2 there, and that all works out. So let's try the other way around. We force that to be a 3, 6. That's a 2, 4. So this is odd. Odd. They're equal parity now. Whatever this is now has equal parity. An even number will never change parity, which means these must have the same parity. Which means that can be done as with 2 and 8. Which can't be done. That breaks it. So if I have 3, 6 as my chosen bit here. Yeah, so if I have 3, 6, and that's 2, 4. That's odd. That's even. Which means this area sums to odd. So I'm going to put a 1 there to show that this side, that those together give you odd. That is an odd. That is an even. So together, both of those also give you odd. All of this together is odd. Because that's odd, odd. Sorry a second. This is odd plus that makes even. Odd plus even. So it makes odd. Which means these need to be opposite parity. 8, 9 works. Yeah, okay. That's fine. I just effed up the math. Because that makes... Yeah, okay. Damn. Yeah, okay. Now that I actually pieced it together to make sure that I'm doing it correctly. That unfortunately has no issue. They would just be both 8, 9. Which means... Is there a way that I can... resolve this list then? Well, let's recover the purples here. This has to be there. So this is either yellow or red. Yellow or red. Yellow or red. This is yellow, blue, yellow, blue, yellow, blue. No matter what, yellow is accounted for. That means this is blue, red. Sweet, so we actually do have like a dual pair cycle here. So whatever this is, must be this. In terms of parity. So for this is not. This is red. That can't be red. That can't be red, which means that can't be red. Which means that's 8. It has to be 8. Which means that has to be 4. Which means that's the 3. That's the 6. Which means that is the 2. That's the 9. And now we can resolve the rest of this now. Which is now that this is here. I show that this has, yeah, so this is a 4, 3, whoops, sorry, 4, sorry, that's the 2 to 1. That's the 3, that's the 8. Yeah, because black is 2 to 1. Yeah, because those have to be opposites. My bad, yeah. So one of these has to be a 3. Cool. But now, oops. So now we have these. What does this sum up to? 12 plus 27 is 39, which is what we have at the moment, 39. And now we have 6 plus 9 times 4. 6 plus 36 is 42. So I either have 14 and 5, which breaks, or it's 5 and 7, because that makes 10, which brings it to 49, and 7, which brings that to 49. Puzzle works. As does brain. Here we go. All the blues are now out of this area. These must be red yellows. 2, 3, 4, 5. Yeah, this also has to be red yellow. This actually can't be a red because we already have all the reds in this area here, and that has to be the 8. And that can't be yellow, so it has to be red, blue. One of these is yellow, one of these is a red. Which means that has to be a red. That works out. Which means these are all yellow, blue. That is also a yellow, blue. We need to have one more red in this area. Red, yellow, blue is all the way left over. There has to be at least one blue. Whatever. There has to be a blue here, which means there has to be actually, yeah. There has to be at least one blue here. But there could be 2. Okay, so then that's no problem. Yep. This has to be 4, 6. 4, 5, 6. 4, 5, 6. 4, 5. 5, 6. One of these needs to have the other 7, 8. Whichever one it is determines that loop. Let's see if this is going to disambiguate something somewhere. Like, this just can't be a 4. If that's gonna be the other yellow, somehow, and that breaks apart, that'd be really neat. Because then it forces the 4 up here, and then maybe a whole... Oh, actually, the 4's already up here, because it's 6, 5, and 6. Cool. Which means we have a 6 somewhere in there. But low priority. 5 could be here or up there. This is also red, blue. One of every, one of every. That means that we should have one of every here, and we don't, therefore that has to be a red. This has to be one of all 3, this has to be one of all 3, which means these have to be yellow, blue, in order to have an equal number of each. Okay. Do I have any... So 1, 3, 6 are the numbers that we're working with. Unfortunately, I don't have anything much concrete. Actually, yeah, this is one of all of them. This is one of all of them. That means that these have to be different. They have to be different in order for this to work. Because if they were if they can't both be yellow, they can't both be blue. So yeah, which means that black is separated by 2 to 1 ratio. So we have 1, 2, 3. Oh, not 1, 2, 3. It's 2, 3, 4, 6. This can't be 2. That can't be 4. Which means that can't be 2. That can be 4. That has to be 3, 6. Which means, cool. We have a 3. Basically, so 3, 6, 3, 1, 3, 6 missing from this row. That can't be a 3, 6 because we have both of them there. That has to be a 1. That's a 3, 6. Those are actually, funny enough, the same 3, 6. So we either have a 6 down here or a 3 there. Neat. The other one is, this can't be a 6. Where does 2 go in this area? Actually, we have to have yellow. So yeah, that's, sorry. That's a blue, which means that's a yellow, which makes that a 4, 5. It makes that a 2, which makes this a 1, 3. Okay, I'm following. I'm following. I got this logic down. We have a lot of things that this could be here. Do we have any other forced anythings that I'm missing? There has to be an 8 up here. There has to be a 4 up there. Almost all of the entropic lines are already done in terms of, like, parity. These have to be consecutive. And this, but we don't know anything about the coloring. We just know that that's 1, 2, can't be 3, can't be 4. 5, 6, which makes that a 1, 2, can't be a 3, can't be a 4. 5, 6, can't be a 7. Interesting. They're forced to be 1, 2, 5, 6, which is a blue, yellow. These are the same. That's interesting. So for whatever this is, If it's a 5-6, it kills the 4. If it's a 1-2, then that's a 3 there. And that forces it out of that area then. Cool. Very, very cool. Indeed. Knocking something out of one will knock something out of the other. That's super very interesting. What else do I have to work with? Oh, well, I should probably uncolor these. Like, oh, here we go. That's a 1. That's a 3. I don't know, I didn't have that before. That's a 3. That's a 3. That's a 6. That's a 3. That's a 6. Yeah. That's a 5. Yeah. Which means there must be a 6 down here. That's a 4. 5. That's a 4. That's not a blue. That has to be a blue because it's on an entropic line. That has to be a 1, 2, and that's 1, 2, 7, 8. Sweet. Inch by inch. That can't be yellow. That can't be blue. That's blue-red. One of these has to be a 4. Ah, wait a second. 4 can't be that. That has to be a 4. Which means that can't be a 4. Or a 6. That's a 5. That's a 6. That's the 4. Ooh, am I gonna get a sub-hour on this? I forgot to put the timer up in the top right when I wanted to start, but not a huge deal. Huh. The hypothesis. That is going to break out of the this weird awful pattern we have at the moment. Oh, these also have to be different, don't they? These have to be different. These have to be the same. I just realized. Freak. But yeah, this is gonna do something like, oh, there's a 2 somewhere already in this box. So it means it can't be 1 next to 2, can't be a 2, can't be a 3 because we already have 4 next to it, and it can't be a 2. Then it can't be a 4, can't be a 5. So it's like, oh, it can't be a 6. It has to be both red. Something like that. So it's either a 2 in there or 7, 8, 9, which is double red. If it's 7, 8, 9, then that forces that to be a 1, 2, and then put things here. But having those both be red has other issues. Like whole other, like, we have to resolve kind of things. Like, not, I guess, issues, probably not the right word, but other considerations. I don't know why I said that couldn't be an 8. Yeah, I'm gonna remove that for now. This is a 7, 9. That's a 1, 7, 9. Even though that's not actually part of the entropic line, that still needs to be a red because, red's in the area. I don't see an obvious step to make now. Oh, excuse me, sorry. Yeah, I don't see an obvious step to make. It's kind of gelling up. So these are the same color. This is the opposite color. Either way, you're either including all the blues from here or all the blues from here. Which isn't really a problem. We had to have one blue here. So all that does is say where the other blue has to go. Ah, there needs to be a 1 here. Because this has to be different. I should mark that as a 1. It seems much more spicy, because that's the only one that doesn't immediately resolve our conundrum. If we do that, then we... Yeah, so if this is 5, 6, that has to be a 1. Huh. Where's the next step? Does it have... Is it this? Is it like recognizing can't be? It can't have a 2? Ah, wait a second. So it can't have 4, 5, or 6 in it. That has to be blue. Yeah, it has to be like this. They have to be the same parity as well. So either we have... Sorry, not yellow. Red. These have to be the same parity. Which means this has to be yellow, that's yellow, that's yellow. Realizing that this saw the different yellows, and that this couldn't be yellow because of this. That's clever. So now that's 4, 5. That's 4, 6. That's a 5. That's a 4. That's a 6. And that has to be a 4. This 4 can't go anywhere else in this box. We had to have a 6 somewhere there. We need to have a 5 somewhere here. Not sure where, but one of those is a 5. Which means if both of these are blue, we break the puzzle. Yeah, so if this is 1, 2, then 1, 2 can go either there. That's 5, 6. That's a 1. Whoops, I'm supposed to do that. Which means these aren't blue, which means that's blue. Which means that's blue, that's red. That's 7, 9. That's 2. That's 2, 3. It can't be a yellow. Could be a red. Do we have another red blue? Well, this is also red blue. Do we have any like locked in? Anything locked in by accident? I mean, one of these has to be a 5. That doesn't tell us very much. Do I have all the 4s? I do. Do I have all the 5s? Not even close. 6s. Getting close, but not quite. Well, 6, 6, 6 forces one of those to be a 6. Which is cool, I guess. I guess we have a 6, 6 something pair there. Neat. Need to have an 8 somewhere there. But yeah, there's no more inching. We need to have a 1 in there. That's either 7, 9 or 5, 6. Well, actually, you said you have both 5, 6 and 7, 9. Well, one of. This can't. So, this could be a 6. But either of these could be 5s. We unfortunately don't know. Hmm. 47 minutes deep, and I still feel like I'm gelling just a little bit. Just not quite resolving the way I want to. Aha, got it. 2, 3. Could this ever be a 1? If this is a 1, this needs to be a blue as well, but it can't because that would be a 1. And we already have the 1. That's the only way that only thing that can be. That means this is the 1. That means that these lose their blue, lose lead red. That also has to be. That means that this is not a 1, 2. Which means that loses its blue. That loses the red, which means that's on a 7, 8. We don't have the 1, 2. That means this is 1, 2, 3. That can't be the 2. So that's the 2. Those can't be consecutive. Okay. Now we're cooking with gas. That's 2, 3. That's 1, 2, 3. That has to be a red. Don't know much about it. It actually gets to know that it's 8, 9. Oh, come on. Is this actually not cracking apart yet? Ah. That's the 3. That can't be the 3. That can't be the 1. Which means one of those are blue. That can't be a red. So one of those is a red. One of those is the yellow. This has to be red, yellow. Sweet. That can't be a 1, which means that's the 1. So there has to be a 1 in this column. Can't be there. Can't be any of those three guys. We said it can't be that because of that. Can't be that because of the 1. Which makes that a blue. It's also a blue. Which makes that a yellow, red. That could be a 2. Or that could be That's a 7-9 as well, because this season 8. That's season 8, which means that has to be the 8. That's a 7. Which means there must be an additional 8 up here. Which means, because that... Yeah, 8 isn't there, 8's not there, so there has to be the 8 here. Which means this has to be the 9, which means that's a 7. Which means that's the 9. That's a 9. Oh, that's a 5. We said before. That's the 9. Oh, is it 2? 7? I don't see a 2 or a 7 anywhere. That's a 5, 6. Yellow. Blue, red. That's a yellow, that's a red. That's not a 9. Could be a 6 still, unfortunately. Don't actually have any resolution about that quite yet, which is very frustrating. How very close we are to finishing this. What am I missing? That's an 8. That's a 7. That's a 9. That's a 7. That's an 8. A 9. That means that can't be a 9 either. No, come on. Break apart, break apart, break apart. That can't be a 1. Three, 7, 9, 8, 9. That can't be a 7. That's a 9. That's a 7. That's a 6. That's a 7. Which means that's not a yellow. That's not a red. Which means that's the 7. Which means that's a 2. Yep, which means that can't be a 2. Also a 1, 3. 2 can't be there. That has to be a 2. That has to be a 3, 2, 1. 3, 2, 1, 3. Well, the 3's done. That has to be a 2. That's a 9. That's the 8. That's the 7. That's the 5. Oh, come on. That's the 6, 8, 9. That can't be an 8, right? That has to be a 6. That's the 9. That's the 8. 5, 6, no resolution there. 1, 2, 3, 4, 5, 6, 7, 8. Deadly patterns. This has to be the 5. That's the 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 5, 2, 1. Whew. That's about 53 minutes. That is a brilliant puzzle. I'm just going to quickly undo that. Let's go here and just get rid of all of these. All those are blues. All those are blues. All those are blues. Just so we can... Oops, sorry. All those are reds. We can admire the finished puzzle. That was a solid puzzle. That was tricky. I really like the break-in of having to do the arithmetic and the modulus 3 in my head. That was a very interesting puzzle. Thanks for sharing it with me. And as always, have a great one.